Okay guys, this is problem number 2, rotation 1. Just going up here, clicking my little pencil. I'm going to, okay, it's freaking out on me. Hang on. I should have made a new layer. No big deal. We're going to let this be our writing layer. I'm excited. No, we don't want to do that. We're going to let this be our drawing letter. Why do I not have my, so we get the background layer. Now we're cooking with grease. Here we go. Chala merry-go-round, clockwise 95 degrees. Immediately convert 95 degrees divided by pi 180. It sure would be nice to be able to just use the same number right here each time. What would that be if we decided to do that? Okay, I'm gonna go get me a calculator. Accessories. Calculator. Let's do 3.14. Clear that. View scientific. Does it give me a pi? Yes. Pi divided by 180. So that's going to be 0.0175. 0.0175. 0.0175. 0.0175. So if you want to, you can always remember just to take this number times 0.0175 and that will give it to you. Let's see how close that is just in case. Uh-oh, I lost my handy dandy calculator. So let me go find it real quick. Accessories, calculator. 95 times 0.0175, clear. 95 times 0.0175, clear it one more time. 95 times 0.0175 should give me 1.66. I was right. Go back and get your pencil. 1.66, right? Radians. Okay. How far is the child from the center? That's my radians. You know that d arc is equal to r theta, right? My d arc is 4.5 is my distance. My r turns out to be that 1.66 turns out to be that. Divide by 1.66 divide by 1.66. My r turns out to be, handy dandy calculator, my r. Why do I keep killing the calculator? I don't know, because I'm a goober, but not my favorite goober. Let's change this view to standard. It becomes 4.5 divided by 1.66. Make sense? So that gives us the radius. That gives us a radius of 2.71. What's my units? Meters, if I'm not mistaken. Now the next question says, next part says, let's go back and review. Next part says if the move took 1.7, find the angular speed. Angular is omega, so we need a formula with omega in it. We're going to divide by omega, divide by omega. So T equals theta over omega. T is equal to, what was my radians? 1.66. What was my time? Let's check it out. 1.5 seconds. Uh-oh, my S's look like my 5's. That's 1.5 seconds, right? And this is radians. So this is, oops, my bad. That should be omega equals theta over T. So let's erase all this junk for a second. That should be that should be omega equals 1.66 over 2.71, right? Was that the time? Let's confirm that time, 1.5, right? So let's undo that a little bit. The time was 1.5, right? So W is equal, hand it in the calculator, 1.6 divided by 1.5. 1.6 divided by 1.5, 1.07 radians per second, right? That's seconds. Pitiful, but you get the idea. Now, the cool thing about this is, you know, one revolution is 2 pi radians. You have 1.07 radians. I don't like that. Do 1.07. Let's clear this whole screen. Uh-oh. Why is that red? My bad. You know, one revolution is 2 pi radians. You have 1.07 radians per second, right? And I know there are 60 seconds in a minute. So, bam, 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 I'm left with what? Revolutions per minute. So we're going to take 60 on top times 1.07, and I'm going to divide by 6.28. Cool. 10.22. So I get 10.22 revolutions per minute. That's looking good. Yeah, good enough. I like. That's number 2, rotation 1 worksheet. Cool.